The Physics of Aristotle is one of the foundational books of Western science and philosophy. As Martin Heidegger once wrote, the Physics is a lecture in which he seeks to determine beings that arise on their own, tau phi epsilon sigma epsilon iota nu tau alpha, with regard to their being. Aristotelian physics is different from what we mean today by this word, not only to the extent that it belongs to antiquity, whereas the modern physical sciences belong to modernity. Rather, above all, it is different by virtue of the fact that Aristotle's physics is philosophy, whereas modern physics is a positive science that presupposes a philosophy. This book determines the warp and woof of the whole of Western thinking, even at that place where it, as modern thinking, appears to think at odds with ancient thinking. But opposition is invariably comprised of a decisive, and often even perilous, dependence. Without Aristotle's physics there would have been no Galileo. Bertrand Russell, however, says of physics and on the heavens that they were extremely influential, and dominated science until the time of Galileo. The historian of philosophy, accordingly, must study them. In spite of the fact that hardly a sentence in either can be accepted in the light of modern science, it is a collection of treatises or lessons that deal with the most general principles of natural or moving things, both living and non-living, rather than physical theories or investigations of the particular contents of the universe. The chief purpose of the work is to discover the principles and causes of change, or movement, or motion, especially that of natural wholes. In the conventional Undranischen ordering of Aristotle's works, it stands at the head of, as well as being foundational to, the long series of physical, cosmological and biological treatises, whose ancient Greek title, tau phi epsilon sigma iota kappa alpha, means the writings on nature, or natural philosophy. Books. The Physics is composed of 8 books, which are further divided into chapters. In this article, books are referenced with Roman numerals, chapters with Arabic numerals. Additionally, the Becker numbers give the page and line numbers used in the Prussian Academy of Sciences edition of Aristotle's works. Book 1 discusses the scientist's approach to nature and the world of changing things and the doctrines of the pre-Socratic natural philosophers, Parmenides in particular. Topics include remarks on method, a discussion of how some ancestors viewed nature, and the basic elements of change. Change elements include a lack, which is overcome by its opposite, with both of them belonging to a subject which persists through the change. The 1966 monograph by Connell is a particularly good expansion and defense of the contents of this book. Aristotle's approach to the world, as summarized in Chapter 1, is to start with the most general, albeit vague, aspects of the sensible world before proceeding to specifics. This approach contrasts sharply with that of modern science, which starts with particulars before advancing to generalities. Chapter 2 begins his consideration of the first principles of motion by initiating a review of the opinions of previous thinkers. Chapters 3 and 4 are among the most difficult in all of Aristotle's works and involve subtle refutations of the thought of Parmenides, Milesis and Anaxagoras. In Chapter 5, he continues his review of his predecessors, particularly how many first principles of motion there are. Chapter 6 narrows down the number of principles to 2 or 3. He presents his own account of the subject in Chapter 7, where he first introduces the word matter to designate the substratum of change. He defines matter in Book I's concluding chapter. For my definition of matter is just this, the primary substratum of each thing, from which it comes to be without qualification, and which persists in the result. Aristotle's concept of matter is rather different from what we moderns might expect from the use of the word in modern mathematical science. Descartes axiomatically redefined the concept of matter in the Enlightenment to exclude any characteristics that would make it unsuitable for abstract mathematical treatment. what has extension. Matter in Aristotle's thought is, however, defined in terms of sensible reality as that which underlies substantial change. For example, a horse eats grass. The horse changes the grass into itself. The grass as such does not persist in the horse, but some aspect of it, its matter, does. The matter is not specifically described, but consists of whatever remains in the change of substance from grass to horse. Matter in this understanding does not exist independently, but exists interdependently with form, and only insofar as it underlies change. Matter and form are analogical terms. It is helpful to conceive of the relationship of matter and form as very similar to that between parts and whole. Parts existing separately do not remain parts, but become new wholes. Book 2 introduces the term nature as a source or cause of being moved and of being at rest in that to which it belongs primarily. Thus, those entities are natural which are capable of starting to move, e.g., growing, acquiring qualities, displacing themselves, and finally being born and dying. Aristotle contrasts natural things with the artificial. Artificial things can move also, but they move according to what they are made of, not according to what they are. For example, if a wooden bed were buried and somehow sprouted as a tree, it would be according to what it is made of, not what it is. Aristotle contrasts two senses of nature: nature as matter and nature as form or definition. By nature, Aristotle means the natures of particular things, and would perhaps be better translated a nature in Book 2. However, his appeal to nature as a source of activities is more typically to the genera of natural kinds. But, contra Plato, Aristotle attempts to resolve a philosophical quandary that was well understood in the 4th century. The Eudoxian planetary model sufficed for the wandering stars, but no deduction of terrestrial substance would be forthcoming based solely on the mechanical principles of necessity. In the Enlightenment, centuries before modern science made good on atomist intuitions, a nominal allegiance to mechanistic materialism gained popularity despite harboring Newton's action at distance, and comprising the native habitat of teleological arguments. Machines or artifacts compose of parts lacking any intrinsic relationship to each other, with their order imposed from without. Thus, the source of an apparent thing's activities is not the whole itself, but its parts. While Aristotle asserts that the matter a necessary cause of things, the material cause, he says that nature is primarily the essence or formal cause, that is, the information, the whole species itself. The necessary in nature, then, is plainly what we call by the name of matter, and the changes in it. Both causes must be stated by the physicist, but especially the end, for that is the cause of the matter, not vice versa, and the end is that for the sake of which, and the beginning starts from the definition or essence. Aristotle, Physics 2:9. In Chapter 3, Aristotle presents his theory of the 4 causes. Material cause explains what something is made of. Formal cause explains the form which a thing follows to become that thing. Efficient cause is the actual source of the change, and final cause is the intended purpose of the change. Of particular importance is the final cause or purpose. It is a common mistake to conceive of the 4 causes as additive or alternative forces pushing or pulling. In reality, all 4 are needed to explain. What we typically mean by cause in the modern scientific idiom is only a narrow part of what Aristotle means by efficient cause. He contrasts purpose with the way in which nature does not work. Chance, discussed in chapters 4, 5, and 6. Something happens by chance when all the lines of causality converge without that convergence being purposefully chosen, and produce a result similar to the teleologically caused one. In chapters 7 through 9, Aristotle returns to the discussion of nature. With the enrichment of the preceding 4 chapters, he concludes that nature acts for an end, and he discusses the way that necessity is present in natural things. For Aristotle, the motion of natural things is determined from within them, while in the modern empirical sciences, motion is determined from without. Book 3. In order to understand nature, as defined in the previous book, one must understand the terms of the definition. To understand motion, Book 3 begins with the definition of change based on Aristotle's notions of potentiality and actuality. Change, he says, is the actualization of a thing's ability insofar as it is able. The rest of the book discusses the infinite. He distinguishes between the infinite by addition and the infinite by division, and between the actually infinite and potentially infinite. He argues against the actually infinite in any form, including infinite bodies, substances, and voids. Aristotle here says the only type of infinity that exists is the potentially infinite. Aristotle characterizes this as that which serves as the matter for the completion of a magnitude and is potentially the completed whole. The infinite, lacking any form, is thereby unknowable. Aristotle writes, "It is not what has nothing outside it that is infinite, but what always has something outside it." Book IV discusses the preconditions of motion, place, void, and time. The book starts by distinguishing the various ways a thing can be in another. He likens place to an immobile container or vessel. The innermost motionless boundary of what contains is the primary place of a body. Unlike space, which is a volume coexistent with a body, place is a boundary or surface. He teaches that, contrary to the atomists and others, a void is not only unnecessary, but leads to contradictions, e.g., making locomotion impossible. Time is a constant attribute of movements and, Aristotle thinks, does not exist on its own but is relative to the motions of things. Time is defined as the number of movement in respect of before and after, so it cannot exist without succession, but he also seems to say that to exist time requires the presence of a soul capable of numbering the movement. Books V and Vi. Books V and Vi deal with how motion occurs. Book V classifies 4 species of movement, depending on where the opposites are located. Movement categories include quantity, quality, place, or, more controversially, substance. In fact, substances do not have opposites, so it is inappropriate to say that something properly becomes, from not man, man. Generation and corruption are not kinesis in the full sense. Book V discusses how a changing thing can reach the opposite state, if it has to pass through infinite intermediate stages. It investigates by rational and logical arguments the notions of continuity and division, establishing that change, and, consequently, time and place, are not divisible into indivisible parts. They are not mathematically discrete but continuous, that is, infinitely divisible. Among other things, this implies that there can be no definite moment when a motion begins. This discussion, together with that of speed and the different behavior of the 4 different species of motion, eventually helps Aristotle answer the famous paradoxes of Zeno, which purport to show the absurdity of motion's existence. Book 7 briefly deals with the relationship of the moved to his mover, which Aristotle describes in substantial divergence with Plato's theory of the soul as capable of setting itself in motion. Everything which moves is moved by another. Book 7, 1-3 also exist in an alternative version, not included in the Becker edition. Book 8 discusses 2 main topics, though with a wide deployment of arguments. The time limits of the universe, and the existence of a prime mover, eternal, indivisible, without parts and without magnitude. Isn't the universe eternal? Has it had a beginning? Will it ever end? Aristotle's response, as a Greek, could hardly be affirmative, never having been told of a creatio ex nihilo, but he also has philosophical reasons for denying that motion didn't exist all along. On the grounds of the theory presented in the earlier books of the physics, eternity of motion is also confirmed by the existence of a substance which is different from all the others in lacking matter, being pure form. It is also in an eternal actuality, not being imperfect in any respect, hence needing not to move. This is demonstrated by describing the celestial bodies thus. The first things to be moved must undergo an infinite, single and continuous movement, that is, circular. This is not caused by any contact but by love and aspiration. English translations of the Physics, in reverse chronological order: Glenn Coghlan, Physics, or Natural Hearing; Robin Waterfield, Physics, ed. David Bostock; Joe Sachs, Aristotle's Physics, A Guided Study; Daniel W. Graham, Physics, Book 8; William Charlton, Physics, Books I and II; Edward Hussey, Physics, Books 3 and IV; Richard Hope, Aristotle's Physics, with an analytical index of technical terms; Charles Glenn Wallace, Lectures on the Science of Natures, Books IV, OCLC 37,790,727; Epocrates G. Apostle, Physics, W. D. Ross, Aristotle's Physics, a revised text with introd, and commentary by W. D. Ross. Not so much a translation, but revision of the Greek text, with English paraphrase. Philip Wheelwright, Natural Science, includes Physics I2, 3, 1, 8, in Aristotle, containing selections from 7 of the most important books of Aristotle: Natural Science, the Metaphysics, Zoology, Psychology, the Nicomachean Ethics, on Statecraft, and the Art of Poetry. OCLC 3,363,066. R.P. Hardy and R.K. Gay, Physica in the Works of Aristotle v. 2, W.D. Ross, ed. Archive.org, scanned, so it includes the translator's emphases and divisions within chapters. Wikisource, formatted into books and parts. Online at Adelaide MIT Classics Archive. Online at Boo. At Ancient Greek Online Library. In PDF. PH. Wixted and FM. Cornford, The Physics. Thomas Taylor, The Physics or Physical Auscultation of Aristotle, with copious notes in which is given the substance of the invaluable commentaries of Simplicius, ISBN 1-898910-189. Hathi Trust Digital Library. Scanned. Physics. English translation by Thomas Taylor. Public domain audio book at LibriVox. Classical and medieval commentaries on the Physics. Aquinas, Thomas. Commentary on Aristotle's Physics. Trans. Richard J. Blackwell, Richard J. Spath, and W. Edmund Thurkel. Averroes, Questions in Physics. Trans. Helen Tunick Goldstein. Buriden, John. Subtilisimi Quaestiones super octo Physicorum Libros Aristotelis. Coimbra Commentators, in octo Libros Physicorum Aristotelis. Jandun, John. Quaestiones super 8, i.e., octo Libros Physicorum Aristotelis. OCLC 488,626,102. Mayer, John. Commentary on Aristotle's Physical and Ethical Writings. Ockham, William. Exposition of Aristotle's Physics in William of Ockham. Philosophical Writings. Trans. Philotheus Boehner. Ockham, William. Ockham on Aristotle's Physics. A translation of Ockham's Brevis Summa Libri Physicorum. Orsma, Nicole. Orsma's Commentary on Aristotle's Physics. Edition of the Quaestiones on Book 3 and 4 of Aristotle's Physics and of the Quaestiones 6 to 9 on Book 5. Edited by Stephan Kirchner. Philoponus, John. On Aristotle's Physics. Trans. Ramus, Petrus. Scholarum Physicarum Libro Octo. Simplicius, on Aristotle's Physics. Trans. Romanis, Egidius, in octo Libros Physicorum Aristotelis. Soto, Domingo de, super octo Libros Physicorum Aristotelis Quaestiones. Themistius, on the Physics.